Alright, so this is the test review for Unit 4. So the first problem says, these are the always, sometimes, and never problems. So this says two sides of an isosceles triangle are blank congruent. So here you have to know what an isosceles triangle is. Isosceles is when you have two sides that are the same. So like a picture like this would be isosceles. So isosceles does mean that the two sides are congruent. So that is always. Number 2 says, if two sides of a triangle are congruent, then the opposite angles are blank congruent. Okay, so let's think about that. We have two sides that are congruent. There's something called the base angle theorem that says if those two sides are congruent, then the angles opposite from them are also congruent. It's called the base angle theorem. So that is also always. And then number 3, the measure of an exterior angle of a triangle is blank equal to the sum of the measures of the two non-adjacent interior angles. So here's what that means. Okay, you've got this triangle here. I'm going to extend that piece. Okay, so let's say that you have this angle here that's x, and you have this that's 50. Those two angles are going to add up to be whatever this angle is here. So the measure of an exterior angle of a triangle is always equal to the sum of the measure of the two non-adjacent interior angles. Okay, number 4. In the diagram, the measure of angle 1 is 120. I'm going to put that on there. Measure of angle 4 is 70. And it wants us to find the measure of 3. So this is the exterior angle theorem. See, it shows you the exterior angle of 120. So I'm going to add the two interior. So x plus 70 is equal to 120. And so you would subtract the 70 from both sides. And you get x equals 50. Okay, number 5. If triangle CAT is congruent to triangle RED, the measure of D is 50. The measure of A is 45. What is the measure of T? Okay, so what I'm going to do first, I'm going to go ahead and draw these two triangles. So I've got triangle CAT. I'm going to draw this one with these letters in the same order with where I started the CAT. So I'm going to do RED. Okay, and they're telling me that the measure of D is 50, and the measure of A is 45. Okay, so looking at your congruent statement right here, let's see what goes together. So C goes with R, which we don't know yet. A goes with E, okay, and we know A is 45, so E is also 45. And then we know T goes with D. We know D is 50, so that means T is 50. Okay, we know that all three angles in a triangle add up to be 180, so that's what we need to do. We need to do 180 minus, actually no we don't, because it wants the measure of T, which we now have. T is 50. If we wanted to find that third angle, we would have to subtract from 180. Okay, number 6, given triangle BCD is congruent to triangle EFG, CD is 2x plus 8 and FG is 3x plus 2. What is the length of CD? Okay, so looking at the two sides they gave us, you can see from the congruent statement that CD is congruent to FG. Those are the two sides that go with each other. So if those are equal, I'm going to set these two things equal. So I have 2x plus 8 equals 3x plus 2. I'm going to subtract the 3x. So I have negative x plus 8 equals 2. I'm going to subtract the 8. So I have negative x equals negative 6. Divide by negative 1. And so x is equal to 6. Okay. It does want to know the length of CD, so just make sure that you actually answer the question and then you don't just find x and be done with it. And so it says CD right here is 2x plus 8, so it's going to be 2 times 6 plus 8. So that's 2 times 6 is 12, plus 8 is 20. Okay, number 7, solve the variable. So it says hint, there are 180 degrees in a triangle. So what I need to do is add all 3 of these angles up and set them equal to 180. So I have x plus 3x. So that's 5 x's. I have plus 10 equals 180. I'm going to subtract 10. So I have 5x equals 170. Divide by 5. And so x is equal to 34. Okay, if it asked us to actually find those angles, we'd have to plug that back in, but it just asked for x. Number 8. Okay, so they're just giving us one angle here and they're wanting us to find x. What you have to realize here is that they're also showing you that these two sides are equal. That means these angles that are opposite from those two sides are also equal. So if this angle down here is 35, this other angle down here in the base is also 35. So I have 35 and 35, that's 70. So if I do 180 minus 70, that equals 110. So x would be 110. Okay, for here it says, for each of the following, state how the triangles are congruent if possible. Finish the congruent statement if possible. Okay, so here I'm going to see, this is where we're trying to decide if we can use like SSS or ASA, SAS, hypotenuse leg, AAS. Remember the two that we cannot use are ASS and AAA. So here I can see that we already have sides that are congruent, and I have a set of angles that are congruent. So we need one more thing, but I notice that they both have this middle line in common. Okay, so I can prove that these are congruent by using side, angle, side. So now I'm going to match this up. So I can see that Q, angle Q is going to go with angle T. Angle R, notice I put a little hump on R, and S also has a little hump, so that's going to go with S. And then that leaves me with R. Okay, number 10. Oh no. You'll still be there. Okay, number 10. It says AB is congruent to BD, so I'm going to show that on here. And AC is congruent to DC. So we really need one more thing to prove these are congruent. And again, these share the line in the middle. So I've got 3 sides on both. So I can prove these are congruent by side, side, side. Angle A, that's going to go with angle D. Angle B is going to be with B. And angle C is with C. Number 11. It says R is the midpoint of LF. So R is the middle between L and F. That means that LR is going to be congruent to RF. It also says angle TRL. That would be this angle here. And angle F are right angles. So I'm going to make those right angles. And then it says angle L is congruent to MRF. So that would be this angle here. Okay, so now I see an angle, a side, and an angle, so I can prove these are congruent by ASA. Angle T, and then it's going to go with angle M. Angle R is going to go with R. And L, M, angle R is congruent to angle F, and then M, F, now R. There we go. All right, number 12. Ray DB is the angle bisector of angle ADC. So think about ADC right here. This line is cutting it in half. Okay, so that means that that whole angle is being cut in half, which means this little angle is congruent to that little angle. Okay, and then it says DA is congruent to DC. All right, well, I'm going to need one more thing to prove these are congruent, and they both have that line in the middle again. So now I can say side, angle, side. Angle A is going to go with C. Angle D goes with D. And B goes with B. Number 13 in the figure below, what is the value of X? Okay, so they're showing here that these two angles are congruent. That's what those little things mean, which means this angle is also 30. So 30 plus 30 is 60. I'm going to do 180 minus 60, and that gets me 120. Number 14, here we go. So it says given the measure of angle 1 is 6x, the measure of angle 2 is 2x plus 5, and the measure of angle 3 is 2x plus 15. And it wants me to find the measure of angle 3. And it says the hint is find x by adding all the angles to equal 180, then plug back in to find the measure of angle 3. Okay, so I'm going to add all these x's. So I have 2x plus 2x plus 6x. That's 10 x's. 15 plus 5 is 20. That's going to equal 180. Subtract the 20. So I have 10x equals 160. Divide by 10. And you get x as 16. So that's what goes in this first blank. We first have to find x. Now if we want to find the measure of angle 3, I need to plug 16 in for x. So I'll have 2 times 16 plus 15. And if I type that in my calculator, I get 47. Number 15, classify each triangle by its sides using scalene, isosceles, or equilateral. Remember, scalene means all different. Isosceles means two the same. And equilateral is all the same. Okay, so this first one, you can see they show that two sides are the same. So that means that one is isosceles. Number 16, remember we're looking at the sides, so don't let the right angle throw you off. We've got 4, 6, and 7, which are all different. So this would be considered scalene. Number 17, now here we're trying to classify by the angles. So I don't care about the sides right now. I just want to see if it's acute. That means all less than 90. Obtuse means one angle that's more than 90. And right means it has an angle that's 90. So 17, you can see I have a less than 90, a less than 90, a more than 90, which means this whole triangle would be obtuse. Number 18, you can see 20 is less than 90, 85 is less than 90, 75 is less than 90, so that would be acute. Okay, number 19, these are just review questions. So here I'm just going to distribute this 2. That's 4x plus 10 equals 14. I'm going to subtract the 10. So I have 4x equals 4. Divide by 4. So that means x would equal 1. Okay, number 20 in the diagram, determine the value of x. Okay, these little triangles right here are showing you that these lines are parallel. That means these are considered same side interior, which means same side, remember those are supplementary. So I have 3x plus 60 equals 180. Subtract 60. So 3x equals 120. Divide by 3. And so x here would be 40. Number 21, determine the slope of the line that is parallel to the line that passes through the points 3, 6, and 5, negative 8. So parallel, that means same slope. So I need to find the slope of this line, and then that would be the slope of the line that's parallel. So I'm going to use that formula over there. So m is equal to negative 8 minus 6 over 5 minus 3. So that would be negative 14 over 2, which means negative 7. So the slope of the line that's parallel to that would also be negative 7. Okay, and then the last problems here, I think. 22, so these are always, sometimes, and never. So points B, C, and A are coplanar. So you can see B, C, A. So that would be always here. And then points A, B, and D. Let me erase this. So A's here, B's here, and D is here. Okay, any 2 points can make a line no matter where they are, but 3 points would have to all be on the same line to be considered collinear, so that would be never.